Hello and welcome to the first flipped lesson of the school year. Before I get started, I want to go through a couple of helpful hints to you guys. There are going to be times throughout the video that you hear me tell you to pause the video and actually work through a few problems on your own. I highly suggest you actually do that. That's your independent practice after we've tried a few together. Gives you a chance to see if you know how to do it on your own. And then after you're done working through it, you just start the video back up and it will go through the correct answers. Also keep in mind, you can stop, rewind, pause, fast forward, even replay the video from the very end. So use this as a resource throughout the chapter, throughout the school year, and if you have any questions, don't hesitate to ask in class. So let's go ahead and get started on our first lesson, solving linear and absolute value equations. Before we get into the examples, we need to go through some vocabulary. First vocabulary word is equation. An equation is simply a statement that says two expressions are equal. In other words, you will see an equal sign in the middle of your problem. The solution of the equation is all values of the variable that makes the equation true. In other words, when you're done and you get an answer, to be a solution, that answer can be plugged back into the original equation in place of the variable, and when worked out, will make a true statement. Now, when you are solving, there are a few specialty cases that you're going to come across. They are, the first one being a contradiction. A contradiction is an equation that has no solution or is a false statement when all of the variables cancel. What you're going to see when you get to these problems, your variables are going to disappear completely from the equation, and what you have left should be a false statement. It should not make sense to you. Identity is your other special case, and it's just the opposite. It is an equation that has what we call infinitely many solutions. In other words, there's lots and lots of answers that work, or is a true statement when all of the variables cancel. So when your variables are gone, what you should be left with then is a true statement. So these first four definitions are for solving linear equations. Now we need to look at a couple of absolute value ideas. So let's do some old school review from middle school. Absolute value, when you learned it in middle school, you should have learned that absolute value is the distance a number is from zero on a number line. So it doesn't matter whether you're going to the left or to the right, you're simply measuring how many boxes is it between 0 and that number. And because it is a distance is always positive. So for example, the absolute value of 4 is exactly 4 units. Four is exactly 4 units from 0. Well, -4 might be to the left, but it is also still 4 units from 0. So both the absolute value of 4 and the absolute value of -4 have the exact same result. Our final definition is absolute value equation. This is simply an equation where the variable is inside of absolute value bars. So I have a simple example here. This is actually the simplest problem you would see. This says the absolute value of x equals 5. In other words, this is asking the question, what values of x have a distance of 5 from 0? So if we think about a number line, and 0 is here in the middle, we can go 5 to the right, which would obviously give us an answer of x equals 5. However, we can also go 5 to the left, which would give us an answer of -5. So one thing that you're going to see on these absolute value equations is that they're going to have two solutions, because you can always go to the right on the number line, and you can always go to the left on the number line. So now that we've looked at some vocabulary, we're going to look at some step-by-step instructions to help us solve. So first kind of equation we're looking at is solving linear equations. These steps should sound familiar, but I would like you to write them down anyways. The first step, distribute. I know you've heard this term. That's when you simply multiply the number outside each set of parentheses. Step 2, combine like terms. Another phrase that you should be familiar with. What's important to know, though, is that when you're combining like terms, the terms must be on the same side of the equal sign. You can't look on opposite sides, you can only look on the same side. Step number 3, you want to move all of your variables to one side. Doesn't matter whether you move them to the left side or to the right side, but you want to move them together. Now, because they are going across the equal sign, this time you must do the opposite. And then finally, our 4th step is simply solve the remaining 2-step equation. This is just your basic math. Next, what we are going to look at is similar steps for solving absolute value equations. Now, these I already typed out. These are a little lengthier. The first step is you want the absolute value by itself. What that means is that you are going to move the numbers outside of the bars to the other side. Anything that is not inside the bars needs to be on the other side of the equal sign. Now, the next thing you need to look at is now your distance number. That's your answer, basically. It's the number that's on the other side of the equal sign. And we can make a little note here. Number on other side of the equal sign. Here's what's important. Distance, because that's what absolute value is, distance cannot be negative. So, if that number on the other side of the equal sign is negative, you stop solving right there and you simply write no solution. Okay, no additional solving, you're completely done. If you have a negative number on the other side, you say no solution. Now, if the distance number is positive, we're going to keep going. This is where we get a little different from solving regular equations. If you remember, absolute value equations have 2 answers. Well, 2 answers have to come from 2 equations. So we're going to set up 2 equations. One with a positive distance number and one with a negative distance number. Think of it as clean and dirty. Then, what you should have left are 2 small equations that you can solve. So let's take a look at some examples at this point. First examples we are starting with are just basic equations. These should be things that you've seen back in middle school, definitely in Algebra 1. So our goal, if this is something that's helpful, you can always put that line down the middle to separate your problem. We want x by itself. So the first number we're going to move is the 4. To move it to the other side, we always use the opposite, which is subtracting 4. That leaves us with 5x equals negative 16. We need to get rid of the 5. Well, the 5 is multiplied to x. The opposite, we divide both sides by 5. And that leaves us with an answer of negative 3.2. I am perfectly fine with decimals if they either stop like this or they repeat and you use a repeating bar. I do not allow rounding, so keep that in mind. Next equation. This one has a fraction, nothing too difficult to work with. So let's take a look. This is also a 2-step equation. We need x by itself. Well, this time x is on the right side. We're going to move the 8 first. We're going to subtract 8 from both sides. 16 take away 8 leaves us with 8. We still have 2 over 9x. Now fractions are everybody's, I guess, scared element. This is a very easy thing to get rid of. To get rid of fractions, you simply use what we call the reciprocal. We're going to take this 2 over 9 and we're going to flip it over. We're going to make it 9 over 2 on both sides. That makes all of this cancel. That leaves us with x. And on the other side, if you type in your calculator 9 divided by 2 times 8, you get 36. So those are 2-step equations. What we're going to do now is we're going to start looking at equations that have those other steps that we talked about. So let's take a look at two more equations. Letter A. So we don't have any parentheses. We don't have any like terms on a single side. However, we have variables on both sides. We don't like variables on both sides. We want them together. So if you remember, step number 3 says move all your variables to one side, but you must do the opposite. So I'm going to move the smaller amount. I'm going to move this 4 to the other side, and the opposite is subtracting 4x. 12x take away 4x leaves me with 8x minus 3 equals 21. Now we have a two-step equation. Now you're back to solving the easy part. We want to move the minus 3. The opposite of minus is addition. That leaves us with 8x equals 24. Divide both sides by 8. And now our answer is x equals 3. So that was a situation where we had step number 3, variables on both sides. So let's look at B. B has parentheses. Anytime you have parentheses, you know you always have step number 1, which is distribute. I use arrows to help me. I take a 3 to the y and a 3 to the negative 3 there. So let's see what we have. So let's see what we get when we distribute. The left side does not change. The right side, 3 times, because this is multiplication, 3 times y is 3y. And 3 times, that is a negative 3. Don't ever ignore the negative signs. 3 times negative 3 is negative 9. So now, this problem should look exactly like part A. So go ahead and pause the video for a moment. Finish working through this, and then unpause, and we'll go through it. Okay, so hopefully you had a chance to finish this problem. At this point, we need to move one of the y's. So I'm going to subtract 3y from both sides. That leaves me with negative 27 plus 3y equals, don't lose that negative, that's a negative 9. Now I need to move the negative 27. Don't move the 3, it's the negative 27. I'm going to add 27 to both sides. That leaves me with 3y equals 18. I'm going to divide both sides by 3. And I get y equals 6. Hopefully, you got that problem right. So the last two examples we're going to look at involve all 4 of the steps. So we're going to go through A together all the way through, and then you're going to try B. So we look at A. We have parentheses. We need to distribute. 5 times x is 5x. And 5 times positive 2 is positive 10. This problem has 2 sets of distributing, so now we're going to distribute the 4. Notice I did not draw an arrow to the x. 4 times 2x is 8x. 4 times negative 7, 4 times positive 7 is positive 28. That plus x is very important. We need to bring him down. So that was step 1. Now, we haven't seen a problem with step 2 until now. If you remember, step 2 is combine like terms. Well, if I look over here on the left, those are not like terms. However, if I look on the right, I do have a pair of like terms. I have an 8x and an x that need to be put together. If it's helpful, don't forget whenever you see a single variable, there's always a 1 there. So I'm going to keep the left side the same. The right side, 8x plus 1x is 9x plus 28. And now it looks like example 2, both parts. We need all the x's on one side, so I'm going to subtract 9x because that's the opposite. 5 take away 9 is negative 4x plus 10 equals 28. I'm going to move the 10 by subtracting 10 from both sides. I am left with negative 4x, don't lose that negative, equals 18. Divide both sides by negative 4, and I get x equals negative 4.5. Go ahead and pause the video at this point. Work all the way through problem B by yourself, and then we'll take a look at the results. Okay, so hopefully you have finished B. So let's put up our line. I have two sets of parentheses. I'm going to start with 3 times 2x. 3 times 2x is 6x. And 3 times that is a negative 1 is negative 3. Now, this is a common mistake. The next number you're distributing is not 2. It is negative 2 that you are distributing. Negative 2 times 3x is negative 6x. And negative 2 times positive 4 is negative 8. And on the other side, we keep the 11x. So that was your distributing. Now we're looking for like terms. So on the left side, we have several like terms. We have 6x and negative 6x. Well, 6, take away 6, leaves us with 0. So these essentially cancel. We also have two whole numbers. Negative 3 and negative 8 are both whole numbers. We add them both together. Negative 3 plus negative 8 is negative 11. And we bring down the 11x. So we've skipped some steps here. If you look at what we have left, we're down to one more step to finish solving this. All we have to do is finish getting x by itself. We're going to divide by 11 on the left, or on the right, and on the left. And we are left with x equals negative 1. So that is solving regular equations. The next thing we are going to do is we are going to look at solving absolute value equations. So if we need to refresh real quick, don't forget, get the absolute value by itself. In other words, move the numbers outside the bars. Then look at the distance number. If it's negative, we stop and write no solution. If it's positive, we then set up two equations, one with a positive distance, one with a negative distance, and then finally, we solve each small equation. I lied. We are not to that point yet. We're at contradictions and identities. So let's finish solving these two problems. If we combine like terms, 7x plus negative 4x is 3x plus 6. On the other side, 12 minus 8 is negative 4 plus 3x. And now we need all of the x's to one side. So I'm going to subtract 3x, subtract 3x. Now take a look what happens. Those cancel. But over here, 3x take away 3x also cancels. This is what I talked about when all the variables are gone. We are left with 6 equals negative 4. So what do you think about that? Is 6 equal to negative 4? Well, hopefully you know that that's definitely not true. That is definitely a false statement. And if you end up with a false statement, we simply write the word contradiction. So pause the video, you try part B, and then unpause. Okay, let's see how you did. We got some distributing here. Now, notice I did not distribute the 2x. It just comes down. 3 times x is a positive 3x. 3 times negative 4 is negative 12. On the right side, distribute the 2. 2 times 2x is 4x. 2 times negative 6 is negative 12. Bring down the x. All right, so let's look at combining like terms. On the left side, 2x's and 3x's make 5x's. On the right side, 4x's plus 1x also makes 5x's. And bring down the minus 12. Now we need all of our letters on one side. So I'm going to subtract 5x from both sides. Well, those cancel, but on the left side they also cancel. We're left with negative 12 equals negative 12. Those two numbers are exactly alike. If they're exactly alike, that is definitely a true statement, which means if we look up here, true means that we have an identity. Okay, so now we are going on to absolute value equations. So let's take a look at example 5. So one thing that might be helpful for you guys, highlight the bars. That's the bars right there. Anything that is not highlighted needs to go to the other side of the equation. So we have two things to move. We have a 3 and a negative 2. The first thing we're going to move, just like the previous equations, is the negative 2. I'm going to add 2 to both sides. That leaves me with 6 equals 3. Now don't get rid of those bars. Those bars are important. Now we still have stuff outside the bars. That's the 3. Well, the 3 is multiplied, so the opposite of multiplication is division. 6 divided by 3 is 2. And we still have our bars. Don't get rid of them. So now, that was step 1. Move all the numbers outside of the bars to the other side. Step number 2, look at your distance number. What is my sort of answer right now? My answer is that number right there, that 2. Well, that 2 is what kind of number? Is it positive or is it negative? Well, obviously, it's positive. And according to step 2, if it's positive, we keep going. So now we are on to step 3. Step 3, we write 2 equations. Now here's what's important. The stuff inside the bars are going to go away, but that stuff will never change. So I'm going to keep the W exactly the same, but I'm going to write it twice. W equals, W equals. Then the distance number, which is the 2, one of them is going to be a positive, and one of them is going to be a negative. And if you look at both of those little baby equations, is there any solving left to do on those? And if you look, as you notice, W is by itself on both of them. So we are completely done, and these are our 2 answers. So let's look at B. So I'm going to again start by highlighting the bars, which is that part right there. Now, this time, there's no numbers outside of the bars. The only number is the 11 over by itself. So step number 1, get all those extra numbers gone. We don't have to do anything. Step number 2, look at the distance number. Well, that's the 11. What do you think of that 11? Is it positive or is it negative? Well, in this case, it's positive. So, since it's positive, we move on to step 3. Write 2 equations. The bars don't change. They go away, but the stuff inside stays the same. 2p plus 5 equals, and 2p plus 5 equals. The other sides are where we take the distance number of 11, and we make one of them positive and one of them negative. And now we got some solving to do. Those p's are not by themselves yet. So, on this first equation, easy equation to solve, I'm going to subtract 5 from both sides. That leaves me with 2p equals 6. Divide both sides by 2. I get p equals 3. That is one of my answers. Other equation. Subtract 5 again from both sides. I get 2p equals negative 16. Divide both sides by 2. I get p equals negative 8. That's my second answer. That problem is done. Let's look at C. Part 1, highlight the bars. And that would be this stuff over here. Is there any numbers outside the bars? No. So then we move on to step 2. Let's look at our distance number. Our distance number is negative 5.5. What do we think about when we have a negative distance? We think distances cannot be negative. And as step number 2 says, if your distance is negative, you stop right there and you write no solution. In other words, there is absolutely no work to do on this problem. So those first 3 were kind of meant to be a little easier. They didn't have a whole lot of work to do. Let's look at 2 more together, and then you're going to have a few to try on your own. Let's look at example 6. So, first thing, where are my bars? My bars are right here. Is there a number outside of the bars? Yes, there is. There is a 4. The 4 has got to be moved. Since it is multiplied, I'm going to divide. And I keep the bars, don't get rid of them yet. 16 divided by 4 is 4. That's step 1. Step 2, we look at our distance number. Our distance number here is the number 4. Is that positive or negative? It is positive. If it is positive, we keep going. We are ready to write our 2 equations. Keep the stuff inside the bars the same. K plus 1 equals, K plus 1 equals. We look at our distance number. We make one of them a positive and one of them a negative. Now, these are not done, so these also have to be solved. Very easy to solve. All I have to do is subtract 1 from both sides, and I get K equals 3. That's answer number 1. Over here, I also have to subtract 1 from both sides. I get K equals negative 5. And that problem is done. We have got one more problem to work through together, and then you're going to try the next full 2 examples on your own. So first things first, highlight my bars. There are my bars right there. Do I have numbers outside? Absolutely. I have a 4 and a negative 3. Now, you do not put those together, first of all. We look. The negative 3 is multiplied. The 4 is not. The number that we move first has to be the 4. So I'm going to subtract 4 from both sides because 4 and negative 4 cancel. That leaves me with negative 3 bars, m plus 2 equals negative 18. The negative 3 still has to move. That is multiplied. The opposite of multiplication is division. That leaves me with bars, m plus 2 equals, we end up with a 6. So step number 1 is now done. All those extra numbers are moved. Step number 2, distance number. Distance number is 6. How do we feel about 6? We feel that it is positive. Positive means we keep going. Keep the bars the same. M plus 2 equals, m plus 2 equals. Make the distance number 1 positive, 1 negative. 2 baby equations to solve. Subtract 2 from both sides. We get m equals 4. And on this side, also subtract 2 from both sides. We get m equals negative 8. And that problem is completely done. So now what I would like you to do is I would like you to pause the video and jump over to example 7 and do both parts of example 7 and both parts of example 8, and then we will go over them. All right, so let's see how you did. This first problem, the bars are right here. Do we have an extra number? Absolutely. It is that 6. We need to subtract 6 from both sides. That leaves us with bars, t equals negative 4. And now we look at our distance number. That would be negative 4. How do we feel about negative 4? Well, I just said it was negative. Do we like a negative distance? No, we don't. Negative distances are not allowed, so you should have written no solution and stopped. So hopefully you got that first one right. Let's look at letter B. Are our bars right here? Is there anything extra? No, there is not. So now we need to look at our distance number. Our distance number is 6. Do we like it? Yes, it is positive. So we write 2 equations. Remember, when you're writing your 2 equations, the stuff inside the bars doesn't change. Negative 4c minus 2 equals negative 4c minus 2 equals. Does not change. Then we look at our distance number. We make 1 positive and 1 negative. All right, so let's keep going. We need to solve these two equations. We need to add 2 to both sides. That leaves us with negative 4c equals 8. Divide both sides by negative 4. 8 divided by negative 4 is negative 2. There's one of our answers. Same exact steps on this equation. Add 2 to both sides. We get negative 4c equals negative 4. Divide both sides by negative 4. We end up with c equals positive 1. So hopefully you got both of those correct. Let's see how you did then on example 8. So example 8, let's first highlight the bars. They are right there. Do we have a number on the same side? Yes, we do. That negative 3 has got to go. Well, the negative 3 is divided, and the opposite of division is multiplying by negative 3. So that leaves us with absolute value of v equals negative 4.2 times negative 3 is positive 12.6. Okay, so let's take a look at our distance number. Our distance number is positive 12.6. I just said it was positive. Positive means we keep going. So keep the insides the same. V equals. 1 is a positive distance. 1 is a negative distance. And on this problem, it already says V equals. These are your two answers. Last example, we are almost done with this video. The bars are right here. Is there an extra number? Yes, there is. There is a positive 1. So we're going to subtract 1 from both sides. We get inside the bars 1/2 a equals 4. Let's look at our distance number. It is positive 4. Since it is positive, we keep going. So we have, keep the bars the same, 1/2 a equals. 1/2 a equals. Distance number, 1 positive, 1 negative. Now we have a fraction here that we need to get rid of. And we talked about a fraction way back at the beginning of the lesson where we had 2/9 as our fraction. And I told you guys all you have to do is take that fraction and flip it over. 1/2 flips over to 2/1. We multiply by that same thing on the other side. That all cancels. A equals 4 times 2 divided by 1 gives you 8. Same thing on the other side. 2/1, flip it over. Multiply by 2/1 on the other side. Cancel. We get A equals negative 4 times 2 divided by 1 is negative 8. So hopefully you got those 4 examples correct. So at this point, we are done with the new material. If you would like to start on your homework, you are more than welcome to. You have it with you. Otherwise, I will see you tomorrow in class.